Welcome to Garfield Elementary School's Science Fair 1997. We're glad you could join us today. We're very proud of all our contestants. We've had over 75 entries this year. Our theme this year is Spotlight on Science, and what we'd like to do is spotlight a few of our scientists coming up in the near future.
Hi, my name is Courtney Williams, and I'm in the 5th grade, and my teacher is Mr. Telfer. This is my project. It's called Robotics Demonstration, and I put the robots together myself, and it's mostly just tells how the robots work, and it kind of shows how you put them how they work, because it shows the inside. And I tried making a robotic hand to be the referee, but the soccer ball did not work in it, so did not fit in it, so I couldn't do that. And I just painted the backboard, and I went to the library to get some things off the computer, and I did all that, and my robots are supposed to play soccer with it, with the soccer ball.
Hello, my name is Eleanor Johnston. I'm in 5th grade. My teacher is Miss Israel. I got my idea because I pretty much like to fly paper airplanes, and I wanted to see which one got the farthest distance in. First I had to make them, and then I flew them and made some graphs to show the wing width and the body width. And then I made the graph to show which one went the farthest and how far for the body width. I tried to figure out which one to make I tried to figure out which one would go farthest, and it happened to be the skinniest, longest one. I think it was because of the aerodynamic body. Its name is Flying High because some of them went really high. My conclusion was that it had the longest average, number 2 had the longest average test flight, had the longest body and the narrowest body width. That's on graph 2 somewhere. Its overall wing area was the smallest though, and that really rather surprised me. Yeah, I make them long and skinny.
Hello, my name is Josh Harrison, and this is John, and we're both in Mr. Golding's class in 5th grade. And our experiment was, is there any electricity from fruits and vegetables?
There is not any electricity from fruits and vegetables, as we've tried it we've put wires into these, and we haven't found any electricity in this. We tried all of these combinations, the carrot and the lemon, the carrot and the orange, the carrot and the apple, the carrot and kiwi, and all of these we tried. None of them worked at all.
In conclusion to this experiment, we found that fruits and vegetables do not produce electricity.
My name is Ryan Funk, and I'm in the 5th grade in Mr. Golding's class. My project's called Investigating Acids and Alkalis, and my question is, how does acid affect building materials? And I used a block of cement, and I put it in a glass full of vinegar, and it melted. And my hypothesis was, I think that acid can dissolve most cement, but it matters how much you put in and how much there is, because it might last longer. And those are my procedures. I did it in a few days, and I kept looking after a few hours. And my conclusion is, I found out that vinegar is kind of a weaker acid. It eats away at cement and makes makes it dissolve.
Hi, I'm Stephen Young from 4th grade, Mrs. Baker's 4th grade class. My project is called What Liquid Detergent Will Have the Most Amount of Soap Suds? And my purpose was I wanted to determine the height of soap sud and the time soap suds stayed at the top of the gradual cylinder using different dish detergents added to water. And I just got 30 milliliters of water and added 2 drops of dish detergent, and I shook it 3 times, and I measured how far it went up to. I found out that joy was the most amount, and then the least was ivory. And
Hello, I'm Kobe Vogt, and this is Andrew Busher. We're in 4th grade from Miss Hosterman's class, and this is our project. We studied different absorptions from different materials. We used paper towels, toilet paper, aluminum foil, and waxed paper. Toilet paper broke down immediately, and then it took 5 minutes for the paper towels to break down. We had to add a little bit of pressure, and then in 6 minutes the wax paper broke down with a little pressure, and then a half an hour the aluminum foil was still standing up.
Hello, my name is Katie Daniels, and I'm in Miss Israel's 5th grade class, and I did my science project on the color spectrum, and I experimented with different colors like blue and red, green and red, blue, red, red and blue, and just different colors. And it turned out that they turned different colors. This one turned pink, this one turned orange, this one turned purple, and this one turned turquoise. And I had questions up for people and answers, and the color, the graphs, and different things about the color spectrum.
Hi, my name is Caitlin MacArthur, and I'm from Mrs. Ostrom's class in 4th grade from Garfield Elementary. This is what I did for my science fair. It's growing crystal geodes. What we did was we made a mixture of plaster of Paris and aluminum sulfate and mixed it and put it in a mold. And we let it sit for half an hour. And then we did the other half, and that sit for half an hour. And then we had to mix a solution with the same chemicals, and we put those 2 in there and let it sit for 2 weeks, and here's how it turned out. And here's a sugar crystal, a snowflake, a sugar salt, a salt crystal, a sugar crystal, baking soda, and sand. They are all crystals. And that right there is an atom. That's the smallest thing. Here's how the procedure we did it. Here's what crystals are, and here's another. And that's the materials we needed. And there is the recording log and the purple amethyst. And right here really isn't an amethyst, but we put that in with that to make it look pretty. And when you look at it, it looks pretty cool.
Hi, I'm Eric Walling, and this is Greg Bailey, and we're demonstrating magnetic fields. Our question that we had was called, can you visually map out a magnetic field? And our hypothesis was that we believe that by using iron filings, the shape, size, and field lines can be mapped out for any magnetic source. You take over now.
Hi,
Okay, our results are our first try. We tried with a weak horse magnet, and it didn't turn out very well, so we tried a bar magnet, and that worked. And our conclusion was that all magnets have different shapes, sizes, and strengths. Now, Eric here will be doing a demonstration for us, all right? So tell us what you're doing here, Eric.
What I'm doing is sprinkling iron filings onto a paper with a magnet under it. It should map out the magnetic field in all the field lines.
Now what we're looking for is that thing right there.
Or something like it. The magnet is right here, and as you can see, we have two little dots here for the poles. They look like dots, and in between is the middle. And our field lines are all around. That's basically it. Yep.
Okay, so as you can see, we have a number of future scientists at Garfield Elementary School. I would like to thank all the contestants. They did a wonderful job. We're very proud of them. I'd also like to thank a couple of folks that helped us out on this science fair, our science fair committee, Miss Ostrom, Mrs. Edson, Mrs. Abernathy, Mrs. Whiting, Mr. Telfer, and Mrs. Hayes. They did an outstanding job, and we thank you for joining us on Garfield Elementary School's Science Fair 1997. And with that, I'd like for all of us to say on the count of 3, 1, 2, 3.
Go!